All right, today we're jumping into a topic that powers, well, literally everything in the universe: work and energy. It's a huge deal in physics for sure, but it's also the story of our everyday lives. So let's kick things off with a question you've probably never really stopped to ask yourself.
I mean, it seems so simple, right? You just flip a switch and boom, the room is full of light. But behind that one little action, there's this incredible chain of events, a whole story of power and change. And to really get it, we've got to meet the hero of our story: energy itself.
So what even is energy? The easiest way to wrap your head around it is to think of it as the ability or the capacity to do work. Let's look at a couple of quick examples to make that totally clear. Okay, picture this. A cricket ball is just flying through the air at high speed. It has something that lets it smack into that wicket and send it flying. That something, that's energy. The moving ball has the power to do the work of knocking over the wicket.
Or, think about a hammer. When you just lift it up, you're giving it the potential to do something. Then when it falls, it uses that potential to do the work of driving a nail right into a piece of wood.
So you see the common thread here, right? In both cases, with the cricket ball and the hammer, the objects got the ability to do work. One got it from its motion, and the other got it just from its raised position. This capability is exactly what we're talking about. And there it is. That's our big definition. Energy is, simply put, the ability to do work. If something has energy, it can make things happen, it can cause change. And get this, the object that does the work loses a bit of its energy, and the object that has work done on it, well, it gains that energy. And just like we measure length in feet or meters, we have a way to measure energy. We use a unit called the joule, named after the physicist James Prescott Joule. And it's the very same unit we use for work, which makes perfect sense, doesn't it? 1 joule of energy is just the right amount you need to do 1 joule of work. Now here's where it gets really cool. Energy isn't just one thing. It's kind of like a master of disguise, showing up in all these different forms all around us all the time. I mean, just look at this list. You've got the kinetic energy of a moving car, the potential energy of a book sitting way up on a shelf, and the chemical energy inside the food you eat. But then there's also the heat coming off a stove, the light from your screen, sound from your speakers, the electrical energy charging your phone. It's this amazing variety that makes our world go round. And those first two on the list, kinetic and potential energy, they're often talked about together. When you add them up, physicists call that mechanical energy. The perfect example is a roller coaster. When it's sitting at the very top of a hill, it's loaded with potential energy. Then, as it screams down the track, that potential energy turns into the kinetic energy of motion. And that idea, that energy, changing from one form to another, that is the most important thing we're going to talk about today. See, energy is rarely just sitting still. It's constantly in motion, constantly changing in what we can call the great energy exchange. This whole process has a name, of course: the transformation of energy. It's this simple but incredibly powerful idea that you can change one type of energy into a totally different one, and it happens billions and billions of times a second all over the planet. A hydroelectric dam is a fantastic example of this. You've got all this water stored up in a reservoir, and because it's so high up, it has a ton of potential energy. When they release the water, it falls, and that potential energy transforms into kinetic energy, the energy of motion. This moving water spins a giant turbine, which then powers a generator, and that transforms the kinetic energy into the electrical energy that powers our homes. It's just a beautiful, powerful chain of transformations. Let's do another one. A car engine. It all starts with the chemical energy that's locked inside gasoline. The engine burns that fuel, which turns the chemical energy into a whole lot of heat. That heat makes gases expand, which pushes pistons, and that transforms the heat energy into the kinetic energy that actually makes the car move. Some of these changes are way simpler, though. Think about an electric iron. It just takes electrical energy straight from the outlet in your wall and transforms it into heat energy. That's it. A nice, clean, one-step conversion to get the wrinkles out of your clothes. And look at that, we're right back where we started. When you flip that light switch, electrical energy flows into the bulb. It gets converted into heat energy first. That's why old light bulbs get so crazy hot. And then, that intense heat makes the little filament inside glow, transforming heat into the light energy that fills up your room. Mystery solved. And we can even run that process in reverse. A solar cell does the exact opposite of a light bulb. It takes in light energy from the sun and transforms it directly into electrical energy. It's a super clean, direct conversion that is becoming more and more important for our world. Okay, but there is one little catch. In the real world, these transformations are almost never 100% perfect. It's not always possible to convert all of one kind of energy into another. So, when you turn on that light bulb, not all the electrical energy becomes light. A lot of it is lost as waste heat. Now, the energy isn't destroyed, it can't be, but it does often get turned into forms that we can't really use. And that's a fundamental rule of the universe. So, let's put all the pieces together. These energy transformations, they're not just some abstract thing from a physics class. They are literally the engine that runs our entire world. And no, that's not an exaggeration. I mean, from the tiny chemical reactions happening in your cells right now to the massive weather systems circling the globe, every single process, big or small, is driven by the flow and transformation of energy. And where does all this energy come from? Well, the sources are just immense. The sun is the big one, of course. It's basically a giant fusion reactor in the sky. But we also tap into the incredible power locked inside atoms, the geothermal heat that radiates from the Earth's core, and even the relentless push and pull of the ocean's tides. Which brings us right back to the beginning. That simple, everyday act of flipping a light switch, you're actually the final step in an incredible journey. A journey that might have started as potential energy in a dam hundreds of miles away, or as chemical energy in coal deep underground, or as light energy that traveled millions of miles from the sun. You are completing an amazing chain reaction. You know, one of the most fundamental laws in all of science is that energy can't be created or destroyed. It only changes form. So, my final question for you is this. Just look around you right now. The screen you're watching this on, the sounds you're hearing, the device in your hand. What energy transformations are happening all around you to make this exact moment possible? Just think about it.